And God bless you and greetings, trig honor students. This is the video I promised I would record in preparation for this upcoming quiz tomorrow, Thursday. That will be the 16th of April, or for the blockade people, that would be the 17th. I trust this will be helpful to you. I'm going to start with the first one here, and it talks about our study of trigonometry, seeing the importance of right triangles. The father of righteousness or rightness has something to say about this. He's got something to say about everything. And here's a verse that captures his interest in these triangles. So this verse would be from Psalm, and it tells us that the Lord is righteous. Not sure I'm getting such a blob there. Let me try another pen. Much better here. The Lord is righteous. Three things here about the Lord. Just like we have three sides to a right triangle, He loves righteousness. And I trust you do too. I wish I did everything right, but I love it myself. Love what's right. And the third thing here is His countenance is upon the righteous. Countenance is upon the righteous. That's upon you and upon me through our representative Jesus Christ. He's always got Jesus at His right hand, and He represents us. So He always sees Him. Okay, the second batch, well, we got batch 2 questions here. 1, 2, 3, 4, 5. Find the exact value of each of the following in questions 2 through 5. Sign to the negative 1 of 1. Should really have put a parentheses around this one right here. Let me see if I can get it in. Not quite. But sign to the negative 1 of 1 simply means this: the angle whose sign is 1. If you think about the unit circle, you'll know that that angle is going to be 90 degrees or pi over 2 in radians. I like for you to keep the radians fresh in your mind. How about this one? Cosine to the negative 1 of a half. It says the angle whose cosine is 1/2, and that would be an angle of 60 degrees in the first quadrant. Or in radians, what would that be? I'm sure you know it's pi over 3. This one here, I don't have it properly, but it's the tan of the angle, whose tan is negative root 3. And that would be, sometimes I have to think of the tan in terms of the sine and the cosine. And if you think about it, let me see if I can maybe, oops, I don't know if I've got room to do it. But sine and the cosine, let's see if I can put it up here. You know that tan is the sine over the cosine. So if we locate on the unit circle a place where we have a square root of 3, it's going to be where the sine will be square root of 3 over 2. That's what we really want. So if we come all the way around here, this would be a position of, let's see, all the way around, angle will be 150. Can I make that? And let's make it like this. 150 degrees. That would be where the cosine would be something and the sine would be something else. Now for 150, the sine would be a half and the cosine would be square root of 3 over 2. That's 150 position, or 5 pi over 6. And now, how do we get the tan to be negative? Well, I made a mistake right here. The cosine is negative 1/2. I'm sorry. The sine is 1/2 and the cosine is negative root 3 over 2. That's what I should say, because it's negative in the x this way. So now, the tan being the sine over the cosine, it's going to be the sine, which is a tan, is sine over the cosine at that position. That would be sine is 1/2 over cosine is negative root 3 over 2. And when we flip and multiply, we get the following. 1/2 times negative 2 over root 3. 2's will cancel, so we'll be left with negative 1 over root 3. We multiply top and bottom by square root of 3. Answer here would be negative root 3 over 3. So my question really should be like this: negative root 3 over 3 for this answer here. I hope I did that right. Alright, let's take another one. Take a look at this one. We're looking for the angle whose sine is negative 1/2. And what we should really do, what I should start you off saying is, where is the sine negative? Sine is going to be negative. As we remember, all sins tainting Christ, the sine is going to be negative either here in the third quadrant or the fourth quadrant. So we could take a third quadrant angle somewhere here. And if you remember, sine is 1/2, negative 1/2 for an angle of 210 degrees. That would be in the third quadrant. The corresponding radian measure there would be 7 pi over 6. Could also have it in the fourth quadrant. For the fourth quadrant, it would be all the way around here, almost to here. So that's going to be 11 pi over 6, or 330 degrees. Okay? For number 6 and number 7, it's just a matter of using your calculator, so I'll just leave that to you. Just make sure you're set in radians. I'm sorry, you're set in degrees, and it's going to be your second function. Okay, so if I could do this quickly, wish I could show this to you, but I trust you're okay with that. We just do second function, and that would be over sine. And let's see, it's got 0.47. So let me, this will be second function over sine. Let me try again. I didn't get it that time. I'll try one more time. Let me see. This is, am I in degrees? Let's make sure my mode is in degrees. 0.47 second function over sine. Yes, I think I got it this time. And to 2 decimal places, it'd be 28.03. And this one, we're looking for the angle whose tan is negative 20. So what we do is we take and do the second function for tan at negative 20. So negative 20 and second function tan. I got a negative angle here. It's negative 87.13 degrees. And that makes sense because I know the sine is positive in the first quadrant. This is a first quadrant angle in degrees. And this is a fourth quadrant angle here. Let's say you start here and you go this way. So this would be my position approximately for the 87.13 degrees, and that's negative because we're going clockwise. All right. Use a sketch to find the exact value of the angle whose sine is negative 3/5. This one is one I really want you to use a sketch for this. You look at this and you say it's negative, and then you have to determine which quadrant you're going to be in. For sine to be negative, it's not going to be the first or the second, it's going to be in the third or the fourth. I think I did it in for the fourth quadrant in class, so let's do it for a third quadrant angle right now, because it's either third or fourth. And make sure that you set up your reference angle properly. This would be your theta here, and this is your angle right here. So you say theta equals sine to the negative 1 of negative 3/5. That means, since theta is the angle whose sine is negative 3/5, you can write sine theta equals negative 3/5. And now, you know that sine is equal to the opposite over hypotenuse. So your opposite to the angle theta here would be 5. And since it's going downstairs, it's not 5, it's negative 3. Times like these, I'm thankful for Jesus because he doesn't make any mistake in life. I make so many, and he did everything for me right. So anyway, theta is here, so opposite would be negative 3, and hypotenuse is going to be 5. Almost finished with this one. Take a look here. We need to find the tan. The tan, for the tan of the angle, we need the opposite over the adjacent. So let's go ahead and find this length here in order to finish it. Pythagorean would tell us that 5 squared is equal to x squared plus negative 3 squared. So here we go, 5 squared equals x squared plus negative